Hi, warm welcome to all the attendees. We have with us Mr. Vinod Kumar Boppanna. He is the scientific officer at Bhabha Atomic Research Center, which apart from being India's premier nuclear research facility, also has thrust areas in cybersecurity systems, such as secure networks, tunneling adapter, endpoint security solutions, information security management systems, and etc. So Mr. Boppanna will elucidate us about the next generation network security tools and techniques and ongoing research at BARC in network and information security. Please give an applause for Mr. Boppanna. Over to you, sir.
Thank you. Could you see the screen? My screen? Hello?
Yes,
Am I
sir.
audible?
Yes, sir. You're audible, and your screen is also visible.
Thank you. Thank you. Thank you so much. So, good afternoon to all. My name is Vinod Kumar Boppanna. Actually, this presentation is supposed to be given by my head, Mr. Gigi Joseph, but due to last moment some work, urgent work, I'm replacing him. So let us start the presentation. So what in this presentation I'm going to do is that we are talking about the next generation network security product that we are developing in we have developed in BRC and even its ongoing process. So BRC, being a premier research institute, is mainly focusing on the nuclear technology. So what is because we did so many nuclear experiments in 74 and 98, so we used to face the technology embargo. So many product BRC doesn't get with respect to cybersecurity, and in today's world, cybersecurity became a big challenge with respect to the national security. So we took this opportunity and start developing various cybersecurity related products that are in-house developed. So before going to the one such product called Secure Network Access System, I would like to just show the glimpses of other products that we are developing in BRC. So a few of them are, one is the cryptographic algorithm development. So we do have a team which develops our own algorithms with respect to cryptographic thing. And we even worked on the crypto ransomware detection. So for example, you can see that a few graphs where how the ransomwares behave compared to the normal applications. Like for example, they create so many encryption, like over a period of time that the encryption files will increase, or even the CPU utilization will go high. So like that, we do have our own algorithms to detect the ransomwares cryptographic ransomwares that can run on the endpoints. And we in BRC we have a big network, so our users access so many websites, so many things and over the network. So what we do have is that we do have big data analytics, so which scans all the malwares and everything going through the network, and if anything is done, it will be blocked and also reported to the NSIBC. So that way we are doing all these activities in BRC. Next, so this is coming to the overall gamut of the things that we are doing. And one more thing that we are doing on the part of network information security. So one is called ISMS. Basically, it's an SIEM. So where all our critical services, all the host IDs is there, which pushes all the logs and everything to the centralized server. And there we monitor all the things with respect to any anomalies and with respect to what is happening on the critical servers, etc. And even we do have the Marvel answer, as I said, just said that we do in the network, we do scan whatever the data is being pushed, going out or coming in, and any malware or anything, any virus or anything is detected, it will catch it. And we do have our own secured VPN adapters, because basically in BRC we do have so many centers distributed all over India. So many centers connected to our BRC. So we do have our own VPN servers, and our own cryptographer that have been developed is ported onto this VPN adapters. And one more is Anunista. So basically, this is a securing profiling hardware that is basically deployed on information and controls systems. Okay. Then this is the introduction that I would like to give. Basically, what are the things that we are doing in BRC with respect to cyber security related things. So now we'll come to the one such product that is called Secure Network Access System. So what here it is there, we have so many modules or so many things in Secure Network Access System. I will just go through one by one. One is the NAC part, network admission control. So one is the NAC part, network admission control, and then we have the NMS part, that is called even you can say the network operations center. Then we have a rogue detection. I will come to the each and every part in more describing in the next few slides. And we have the network anomaly detection also module is there. So all these modules work together to achieve the to improve the security of the organization, network organization. I'll come to each and every module in detail. So first is the network management system. So as we all know that every network has a network device like L3s and L2s, so many things. What would basically what NMS is needed is that we do need to monitor these devices, whether it is what is the status of them, even the links, the topological links, whether they are up and down, or what is the bandwidth of the being consumed on the link on the link. So everything. So what in this picture we are showing is that one is the network layer view, like L2 and L3 view, and in the small graph on the top right corner is that what is the end system view. So here we just not only just showing the devices, network devices, but we are also showing the endpoint view also. Like you want to see that what are the devices that are connected to the switch on a particular switch. You can just click on that. You can get the complete what are the all the endpoints that are connected, and even their status. What is any problem is there in that endpoint. So all this view is completely displayed on one single view. And we can click on right just snapshot also there, where you can do a right click and see what are all the things that you can do on the endpoint or a network device. For example, you can see the properties of the device, you can access the status, you can access all the VLAN information, you can even see that end systems connected that are connected to the network device, all those things. Then one such feature in NMS that we incorporate is the routing anomalies, because at times, even for example, let's say for example take a multicasting. So in multicasting, what happens is that if the forward path and reverse path is not same, then multicast cannot work. So what we do have here is that one is that routing anomalies detection, where sitting at central place you can see that from one location to another location what is the forward path and what is the reverse path. So that because manually running from, let's say you have thousands of VLANs in your organization, so if you want to do this manually, trace route from one network to another network, it is not possible. That's why we have one module in NMS where it is automatically does for each and every VLAN and give you the report, what is the forward path and reverse path, and any anomalies are there, like from one network to another network the forward path is not same as the reverse path, so you can just correct it basing on the report that has been given by that module. Then another thing that we do is that rogue detection. Basically, to secure the organization, what we want to achieve is that any unauthorized device should be catched. If anybody, especially this is important when you have a wireless setup network in your organization, because it can be connected by anybody, just wireless, they switch on and they connect to the wireless. So what we do here is that we do all the scanning of the entire network and even catch anybody intruding into your network which are not authorized. So even we can identify what is the type of device that is connected, what are the OS that is running, basically what the profiling of the device that is connected to a network, and we can highlight to the administrator and so alert, and even we can isolate it. Like for example, he is connected to some part of the network, we can completely isolate it and throw him out of the network. Just like this in snapshot of how we are doing it, the entire scanning of the network and finding anywhere wherever any unauthorized devices are connected, and highlighted it and isolating it from the network. Then the more important part, one more module is the network admission control. So as a name itself, it says that whenever any device comes onto network, it has to follow the security posture of your organization. So like for example, if I say that any endpoint has to have the antivirus installed. So if any antivirus, if the endpoint is found out with none of the antivirus that that your organization is supporting, then it will not be allowed to connect to the network. So there are so many parameters that can be configured to check to make a policy. And here in SNS, what we did is that it is nothing any like there is no hard code of only one policy should be there. You can make n number of policies and you can apply to n different systems, different policies. There is no that the same policy should be there with all the systems. Like for example, some of the parameters we listed here is that we can check the operating system type, operating system version. We can check even that network profiling like IP address, MAC address, wherever it like the location means wherever I configure that this is the switch or this is the port, it should be connected. It should be connected to that only all the time. They should not change it, they should not move it from that location. Even antivirus installer, as I said, even what application, even whitelisting, blacklisting of applications, process, ports, everything I can do with respect to the policy. And any endpoint, if coming onto the network, has to adhere to the policy, then only whatever authorize it for that. Even we have authorization also, not just the authentication. The next part is that we have authorization. So whichever machine is authorized to go, only that access will be given. Like for example, I'm allowed to access only a few servers. Only that servers I can access. Rest of the servers I will not get any access. So basically, SNS is acting as like a firewall also. We do call it as a host-aware firewall, where it is doing the security, it is checking the security posture of the endpoint and only giving access if it is fine. Otherwise, it is not giving any access. So just like for example, some of what we do is that as I said, it is having a firewall sort of thing. So we do have a blocking at two levels. One is we want to block it at SNAS level itself, where if any, like for example, antivirus is not running, so we do you can say that it should not move out of your network, like any service side servers or like internet or intranet, they should not access, but you can move in the local network. That's then you can set that block at SNAS. But let's say if there is a very high broadcast traffic is going on, or our broadcast is happening, so then you can block it at the network level itself. So in SNAS, you can configure at what level also you want to isolate the system if the security policy is not met by the endpoint. So that all are configurable. There is nothing like only this is the only parameter that can be checked, or this is the only thing that can be done. Nothing like that. Like for example, even we can say that, let's say team viewer, we don't want to have anywhere in your network. So you can configure, say that anybody, if you are having any team viewer, will be blocked. They will not get any network access. So like that, your all configuration can be done. Like some just so SNAS is acting as a like a firewall that we call as a host aware dynamic firewall, and endpoint where any user trying to go to anywhere and the service side has to first get authenticated. Even in the authentication also, not just the endpoint authentication, we do even user authentication also. So you can configure that for any endpoint whether user authentication is required and endpoint authentication is required. So both you can configure, and accordingly SNAS does that and only give access then only. Basically, user authentication we do have facility to integrate with the LDAP. If an organization has an LDAP, they can integrate with that the SNAS box, SNAS appliance to that LDAP server. Then one more important feature what we have in SNAS is that next, we call it next generation firewall. We do have the traffic shaping and bandwidth control. So many times we face this problem that only one person is clogging in the entire bandwidth, or even so much of traffic is being generated from one system. So we do have all the facility, like you can limit the bandwidth basing on IP, basing on the subnet, basing on the destination. So all those combinations are possible. And even we can do a rate limiting also. Like for example, you have one server where you can only number of connections can be made only over a period of time. You want to limit it. So those are all configuration you can basically set in the SNAS. So if I summarize that, we have a NAC, which is first we do the authentication. That means the policy will be checked, and then the authorization. So whatever network services it should get will be allowed. In that authorization, we can do a traffic shaping and bandwidth control. Basically, what services they can access at what rate or at what bandwidth you can say. So those all things can be configured in SNAS. Okay, like for example, these are the and even because we have a firewall, we do have a firewall statistic dashboard also, where all the combinations can be seen, like what are the top source IPs, top destination IPs, ports counts, traffic, what is the traffic that is being generated over your network, or where the destination is coming. Even actually even we demonstrated many times, like beautiful, like for example, you have a mobile. So many times we don't know even what is happening in which sites actually the programs that have been apps that are installed in a mobile going to which destinations. Just even if as soon as you can see all the traffic that is being generated from your endpoints or mobiles anywhere, and where it is trying to go, even if it is not successful, it may not be successful, but just we can show that all the statistics, like what are the traffic that is being generated from your organization, it is success or it is not success, it doesn't matter. Okay. So where do you place the SNAS firewall? So ideally the placement of firewall is at the end of your LAN, at the end of your intranet, and one side will be all your endpoints, like your laptops, your PCs, your mobiles, all those endpoints, network devices, and the other end it all your servers, like your intranet servers, internet servers, all the servers. So basically SNAS is controlling the authorizing all the access of the endpoints to those servers. So that's where in order ideally we place the firewall SNAS, sorry. So policy. And what we do in addition to that, we do have the SNAS DOS detection and mitigation also. Basically, if any abnormal traffic is being generated in your network devices, in your your endpoints, so SNAS does detect, and it will, as I said, it can block at the firewall or it can block at the network level. So all those things are there. And one more beautiful feature that we have is that normally when you see NMS, so you as we are I had shown you in the earlier slides, you do show all the status of the network devices, status of the endpoints, all those things. So basically, any organization will have a network operations center as well as security operations center separately, where network operations displays all the statistics of the network, and the security operations center displays all the events related to the security things or cyber security related things happening in the network. What we did here is that we did combine this thing, because we want a single snapshot where administrator can see everything in one go. like the status part, the status of the network device part, as well as the cybersecurity incident part that is happening in your network. So that's why you can see some icons here. So basically, this icon indicates something is happening in that network device, something beyond behind that network device. The endpoints connected to the network device are doing something. Like for example, this exclamation mark icon indicates that there are some devices beneath that endpoint, beneath the network devices, where some security policy violations have happened. So basing on that, you can easily identify what is happening in the network, and we provide actions to view it. Like you can do a right click on it and go and see that what are the actions that are, what are the violations that has happened on that endpoint. So all these are beautifully merged and shown into a single snapshot, so that the knock and the sock can be seen at the single with a single view. And we have a dashboard also, basically where we show all this data that is being generated in your network, like what are the new processes that are coming up, what are the new products that are coming up, product means applications installed. So many times, like for example, if it is a very highly controlled environment, like for example a reactor environment, or a very information and control system environment, where you ideally want to see that none of the new process should come every day, or none of the new applications should not get installed any day. So those all statistics you can see where what is happening. This is overall network. Even you can see that even for each endpoint also you can see the same view, like what are the new processes that have come up, which was not found earlier. Today what was the new process, today what was the new application that have been found on that endpoint. So all those things, even what is the new port that have been opened. So all those things you can find it on the dashboard. Like, and one more beautiful thing that we do here is that, okay, you have that all this information, like what is the port that is being opened, what is the application that is being installed, what are the process that is running, but how to correlate things, which process is run because of which application is installed, or which port is opened by which process. All this linking we do here. Basically we do have a like a netstat where all the ports that have been opened, and it can be TCP, it can be UDP, and you can have some filters like which ports you want to monitor, and basically what process this port has been opened. So that also you can find it out, and you can link it. And this process came because of which product, like which application installed, on installation of which application this process has come up. It can be standalone also, but if it is not a standalone, you can even list that which product because of that it has come up. And one more thing, that what is the details of that process, like what we call it as a manifest information, where you can see here the snapshot, like what is the file name, from where it has been run, what is the sign status. Because let's say for example you take a Microsoft Windows, and normally they signed it, Windows does signing of the process, so you can see that what is the status of the process, whether it is signed or is just running from some unknown publisher, unknown product. So all, even that what is a SHA, MD5, SHA1, SHA256, SHA512, everything you can calculate. So that let's say some virus has taken over and replaced some genuine process, you can still find out whether it is actually the process that is same genuine, or somebody has just replaced it with the genuine process name. So all this information you can correlate. Like these are the entire information that we take. Like in case of process, we take the path, argument. Even sometimes at times argument also becomes important. Like some process behaves differently if you pass on some argument. Like that's why we take all these things. What is the parent process, from which user it is running, whether it is running by administrator or it is being run on the name of the normal user. So all these things, what is the CPU utilization, and local also, like what is the remote IP, local IP. So all those things we do take. And because of correlation of all these things, you can entirely take a snapshot of the end system, what is happening there. Okay. And one more thing, what we do have in our SNS is that we do even vulnerability scanning also. So OLD provides a good mechanism to do scanning of the endpoints, where what are all the vulnerabilities that are there on endpoint can be highlighted. So we do push the scanning to happen on the agent. We do have an agent on SNS where that is installed on each endpoint. So from the server, we do a command to that agent that you do the scanning and give the report. So it can give all the report and show all the vulnerability that is there on the endpoint, so that you can take even action also, like to solve to remove that vulnerability. And even that all the what is the reports, to get that reports, what has happened in the endpoint, what is the vulnerability, everything, we do have interface to search it. You can make the query of it and get the report. And one more thing we have in SNS is that USB based control. So many times we in an organization, especially in a sensitive organization, we do have a problem with the data leakage. So some data should not go out through the network. That is, anyway we had seen that how would we do monitor. But otherwise, that copying that information into the USB device or taking it out like that. So what we do have is that we have an agent which runs on the endpoint, and it is controlled. It is monitored through the centralized server, where you can disable, enable all the USB based devices. It is configurable. Let's say you want to only enable only mobiles, but you don't want to enable any storage device like that. You can configure. Also, you can allow the administrator, sorry, user to register it. Let's say you want to allow the user allow the user to register two pen drives, something like that. You can allow him. Only that pen drives can work on their endpoints. So like that, all these things are configurable, like which USB device should work on which endpoint.
Sir, I will have to request you to hurry up because I
Okay,
think
sorry, the
we
last two
have
slides.
next speakers lined
Yeah,
up.
last two slides.
Yeah,
Okay,
sure, sir.
almost done.
Thank you.
Thank you. Thank you. Just last two slides. So the SNS is also we do use in BRC, because this is the product which we developed, and we are using all the products that are in-house developed, and not just in BRC. We have through ECL we have done market. We do sell it outside, and in DAE also we do deploy, and as well as outside DAE also we do deploy. Right now we are around 30-35 installations all over India. That's what we are showing in this map. So wherever it is there, like all the DA units on in the DRDO, NSCS, so all there these SNSs has been installed. And so thank you. That's it, Fanan. So let's make that indigenous secure digital India, and let's walk it towards that goal. Thank you. Thank you so much.
Thank you. Thank you, sir, for the insightful session on BARC's R&D program in network and information security. And also you covered